go ahead and hook it up, single battery, and we'll put a little circuit on it to pump up the volume. Oops, we gotta hook the belt on. Go ahead. See guys, before we put the belt on, Jordan's working right here. He's got his hand under there. Hold it. Before you put the belt on, let him see. Okay, this is without the belt on. You'll notice that Jordan put a magnet over there and a magnet over there, right? And he put a magnet over here and a magnet over here. But watch what happens. Okay, don't grab it. See, when you cancel them, when it's canceled, you can put it anywhere. And it moves a little bit. I mean, we need to be able to tweak these maybe a little on the angle. It looks like it moved on us. Oh, maybe because we're on the wrong side. Yeah. See this side? No. We must have bumped it. But anyways, you get the idea. It's way better. It's not cogging so badly. And we can adjust these. Maybe we can come up with an adjuster, right, Jordan? Yeah. And but you see, these are 50-pound magnets right here, and they barely cog right there. We don't have an adjuster like we need to be able to adjust it in and out and side to side and everything. We're still formulating, but you can see that it's pretty close. You can see it's pretty close. So we're going to hook the belt up for you. We're going to lock it in as if it was locked on place, and he's going to hook the belt on and show you that it'll start up. It'll start up with all that magnetic power. And we'll show you another thing too that we've learned. What we've learned is when you take this magnet off of here, this is the pulling or attraction side, and this side here is the repulsion magnet. Well, that stays, and we're going to take this off, and where's that bar of steel with the ring on the end? Got it? Okay, we're going to substitute like this. This would be like a coil, a core material, and then the coil goes around that, and this would substitute as the attraction side. See that? See me put a bar of steel up to it. And what we learned was that we're going to have a smaller magnet over there, and I'll explain why. But do you got it ready? Okay, hold it. Let him show him the meter. You can hook it up. Here's the meter. See it go up? It's like almost 0.1 amps. This is a full amp meter, and you can see it going round. Okay, stop it and start it again for him. Let's get it on there. Okay, I'm holding it right on there. Go ahead. See it take right off. There's no resistance at all. So that's the goal. Now if we remove, like say we we can feel the vibration of the magnets thumping, because this is so high. This is so high up and everything. So we're actually using this as a measuring stick to see when we're wrong, when we don't have things right. This thing will just shudder on you like crazy if you got a big powerful magnet and it's out of balance. Okay, turn it off for a sec. Where's that screwdriver? And where do I put that screwdriver? You got it? Look on the bar then, I guess, if we lost it. But anyways, I wanted to loosen how do we lose a yellow handle screwdriver? Okay, take that off for him. This? Yeah, just unscrew that a couple of turns and then pop out the magnet. mean, that's really in there. Okay, he's going to slide it out. Okay, now there's no magnet in the attraction side, right, Jordan? Okay, and go ahead and spin it just gently. Spin it around and let them see how it bounces. See how it cogs there? Spin it just lightly. Yeah, like we were doing. See, we were just barely moving it with our hand to get it centered with the other one. And I'm pulling about 4 or 5 pounds of pressure there. I can't get it unless I move it, you know, a couple, 3, 4, I don't know, I don't have my gauge with me, but that's a big powerful magnet in repulsion. Now let's see, try to turn it on. Okay, it's right there, and he's going to try to turn it on. Okay, it goes around to there, but it won't go past. Okay, undo it. Okay, hook it up. See, it tries to move a little. Let go. We'll move it back a little. Go ahead. Whoa, it won't go. Let's try to get a run start. Okay, go ahead. Ooh, it won't go past. And then let's get a little more run start. Go ahead. Oops, your connection there. Oh, there it goes. There it goes. See, you got to give it a start. It will run, but go ahead and keep it running. But it won't break that cog right there. It won't unless you back it up and then start it. And you got to give it a good run too to get it to. There it goes. See it? So, and then you can feel it thumping away up here. Of course, you can feel that with any generator. You can feel cogging, and whether it's just a magnet and a magnet or a magnet and a core material. So your structure has to be different than this in the practical sense. Okay, so, and then here's our running something like 50 or 60 milliamps. It's really small right there, and their motor there is running away. So this is our beginning. This is what we've been working for all along. So what Turion was saying is that you won't see it stuck now. The amp draw is way up, which this motor can handle 5 amps, alright? And it's way up now. It's trying to cog, and it'll go down, but we have a lot more work to do. So you won't be able to break, like Turion said, see it stuck? You can't break the magnetic lock without a starter. So if you had this populated all the way around, Jordan, with magnets, you'd have to have a car starter to break the magnetic lock. It'd be so strong if they were real close together, because these are 50 pounds each. So that'd be a, you know, at least 50 or 70 with a 1/4 inch gap or something. And so that's where we're at, and I wanted you guys to see that it won't break the lock there unless you give it a jump start. Not quite. No. There it goes. Alright, that's where we are.